this video, we're going to look at how you can use the ConsolidatedCountUnique function to perform a quick and dirty market basket analysis. Now, I'm going to do this in Cognos Insight because it's fast and fun that way, but the function's a native TM1 function, and you can model this in Performance Modeler or Architect or any way you like. Now, market basket or affinity analysis is intended to help you understand customers' buying behaviors. More specifically, are customers more likely to purchase some products while purchasing others, so that we can better frame promotions, more effectively cross-sell products, and that sort of thing. This video will focus on a simple example of a software company with very few products and a time grain of years. For a retailer, you might want to do this at the transaction level. In any case, you will need at least a customer and product detail grain, so lowest level of customer and product, to look at this. If you looked at the product group level or various levels of customer tier or something like that, anything above a unique customer, it's going to be much less useful or accurate. In another video, I'll demonstrate how to supercharge this approach so that you can quickly evaluate all products for affinity. But here we're just going to do a quick one-off test of any assumptions we have of what the current affinity might be. So the first thing we'll do is take a look at our data that we're going to use for this. So we've got a simple tab delimited extract here from some system. We've got regions, we've got our customer ID. Again, this is important that this is unique to the customer. We've got the product. Again, this also has to be at the lowest grain. We don't want groupings of products or anything like this when we import, so that we get a more accurate affinity analysis. We've also got the year that it was purchased. And again, this is at the year grain because I'm a software company and I'm interested in products that people purchase together. It doesn't have to be at the same time. If I were a retailer, I would certainly want this at a much more narrow grain and probably at the transaction level. In fact, I may not have customer. My uniqueness will probably be to the transaction level. And then lastly, I've got my revenue number here that's going to tell me how much I'm making off this particular customer for this particular product purchase in this particular year. Now in this case, the file is pretty straightforward, so I don't need to fuss about in the guided import to determine how I want to import this. I'll just do a quick import by dragging that file in, and from that we've built a cube. And of course this cube has the dimensions we talked about, those columns. So we've got customer ID right down to the unique customer. We've got our list of products that we can look at here, so a number of fictitious software products. And we can look at this over time. Now one thing we added, as we always do in the import, that I don't need is a count. So I'm going to get rid of that count, but I am going to insert a new item here so that we can get our unique count of customers. So let's do unique customers as a new element here. And just to make this a little easier for me to write, I'm actually going to set the roll-up type of this expression here to average. Now the reason I'm doing that is that it'll make it a lot easier for me to write the rule. So if I do set cube rules, this will be done as a cube rule. At the time of this recording, there is no function available to let me quickly consolidate just unique items, but the rule is pretty easy to modify here. So instead of a consolidated average, I want to do a consolidated count unique expression. I'm going to set that to 0, and then I'm going to choose what I want to be unique. So I'm interested in unique customers, not products, and a comma. And if we look at the end of this expression, I want to do that not for my unique customers, which is what we had by the default because I've done an average here, but I want those with revenue. I'll click OK. And now we see our unique customers. I'll quickly change the format on that. I don't need to see decimal places for my customers, so I'll use the same format I have here, or we could justify that if we like to say that it was just a, let's do number, we'll do digit grouping, no decimal places. So there's my unique customer. We'll switch this just to be a grid. We're more interested in the data right now. And a quick eyeball of this will probably show you that although total of product here is the sum of all of my products, my unique customers isn't in fact the sum of all of these items, which of course it shouldn't be. We're interested in our unique customers. So what we want here is to spot the affinity of products, and that will be indicated by overlap. If we have a lower number at the sum than we have uniquely for the children, then we know that there's definitely affinity. For example, a customer has purchased both products, so they're only getting added once at the aggregate level rather than for both products. So for a quick example of that, if I look at my two ValueWare software types, I have an assumption that these products are often purchased together by the same customer. So to test that, I'm going to insert a parent here, and I'll call it all ValueWare. And what you'll see, of course, is that at the aggregate level, I only have 1,144 unique customers, while at the child level, I can just quickly eyeball that. I can see that I've actually got 1,743 customers. So what that tells me very quickly is that roughly 600 customers have purchased both products. So there's definitely some affinity there, and if we want to see the math for that, we can actually do just a pure add. So if I create a calculation here that is A plus B, that's very different than a hierarchy. So ValueWare A and B, I see the sum of those two products, and then my last expression is going to be all ValueWare minus A and B, or sorry, A and B minus all ValueWare is going to give me those customers that have purchased both products. So we'll do another calculation of all ValueWare minus A and B, and we'll call this our, and I did that backwards, but that's all right. We'll call this affinity. So hopefully you see that's a very quick and easy way to test our assumptions. So let's try it one more time just for fun. We'll look at another set of products that I believe might be being sold together very closely. So this is our ShareWise product line. Insert a parent to that as well. I'll call it all ShareWise. And I see the exact opposite. In fact, at 62 being the sum of 30 and 32, we know that no one is buying both ShareWise A and B, and it may very well be that those are two similar options of the same product, and very unlikely then for someone to buy both. Again, the math, just to check it, I can do an add of ShareWise A and B, and then for my final expression, I want to subtract A and B from all, and I'll call this A and B affinity, which is 0. Now, of course, my expression up here is backwards. I'd have to redo that to get my actual affinity of 599. Probably also create some percentages from those as well, just so that I can see the percentage likelihood. And when you think about this in the context of financial planning, if I'm creating a forecast for products, even if you don't include the affinity for your contributors, one of the things you might very strongly consider is that when you've got a whole host of products for people to forecast against, you want to minimize the input and the effort of those contributors. Think about if you've got a product line that may be accessories or is always driven by another product. And of course, we don't cover causality here with TM1 or Cognos Insight. We'd be checking causality likely elsewhere. But if we know that a product in fact drives the purchase of its accessories or something like that, consider using this sort of affinity analysis to create a driver forecast for those other products that we're perhaps not as interested in. For example, if I was a satellite company and I sold satellite receivers, Perhaps I know that when a customer signs up or gets a subscription, they're going to need a satellite dish and an LNB to go on that dish or something like that. That's just an accessory. I'm not going to make my contributors forecast that. I'm going to drive those sales based on the affinity from one to the other rather than forcing my contributors to enter every value. So that was our look at quick and dirty affinity or market basket analysis. If you want to check out the supercharged version, we'll take a look at how we could compare all products and see which ones have the greatest affinity. Thanks for your time.